So the answer to the example given at the end of the last tutorial is 12.02. So carbon, using these probably slightly inaccurate numbers for calculations, has a relative atomic mass of 12.02. Now we're going to spend this video looking over a couple of calculations involving the relative atomic mass, based on the formula that we've introduced. The first question is asking us to determine the relative atomic mass of bromine using the table below. And the table gives us two isotopes of bromine with mass numbers 79 and 80. And it also tells us their abundances. We have everything we need to answer this, and it's just a question of using the formula from the last video. So isotope 1 has a mass number of 79 and an abundance of 10%. And if we use the formula, we're multiplying the mass by the abundance of the first atom, or the first isotope. So 79 times 10, and we add this on to the same calculation for the second isotope, the mass number, which is 80, multiplied by the abundance, which is 90%. And what we do now, what we write for our denominator, is a sum of the abundances, which is simply 10 plus 90, which is 100. And if you do this correctly, if you type in the numbers on your calculator correctly, you will get an answer of 79.9 as the relative atomic mass of bromine. Now I said in the last video that you can carry out this calculation having been given something like grams instead of percentages. So if we change these abundances to grams, let's say we have 60 grams of bromine. 54 grams, which is 90% of it, has a mass number of 80, and the rest, which is 6 grams, has a mass number of 79. So we're keeping the percentages the same here. If you write out this sum, you've got the mass number 79 times the abundance, and we do the same for the other isotope. But this time we're dividing by the total abundance, which is 60 grams. 54 plus 6. And we will get, provided you type this in correctly, we will get the same answer. This second question that we're going to look at is slightly more difficult, but if you can do this one and do it confidently, I don't think there's another one they can give you which you would struggle with, to be honest. So we're told that the relative atomic mass of copper is 63.6. We're told the abundances of the two different isotopes, the mass of one of them, which is 63, a mass number of 63, and we need to determine the mass of the unknown copper isotope, which is this one here, or written it as X. So we need to find out what X is. And in this question, we're actually given the relative atomic mass first, and we need to work out one of the isotopes, which is the opposite of what happened here. But we know the equation, so we can just start to write this out. 63.6, which is the relative atomic mass. We've got our first isotope, so we multiply the mass number, which is 63, by the abundance, which is 69.2. We do this with the second isotope. We're not actually given the value of X, so it's 30.8 times X. We'll just write 30.8 X. And the sum of all the abundances, which is what we put on the denominator, is 100 when you add these two numbers up. From here, it's all about rearranging this formula to make X the subject. So the first thing we can do is get rid of this fraction by multiplying both sides by 100. 63.6 times 100 is 6,360. If we times this side of the equation by 100, we're just removing the fraction. We've still got our bracket, and everything on this side of the fraction remains unchanged. What we do now is we need to get, we want to get X on its own, so we're going to take away this bracket, remove it from this side of the equation, and you don't even really have to work out the value inside this bracket, but I'm going to do that. So if we write this out again, 63 times 69.2 is 4,359.6. If we take away this number from both sides, we have 30.8x equals 6,360, take away 4,359.6. And the final step to this is dividing both sides of the equation by 30.8. That gives us x on its own. Now, rearranging is probably the biggest challenge of this question, but if you do it right, you will get an answer of 64.948. Now remember, we're working out the mass number of a single isotope and not the relative atomic mass. So you need to give this answer as a whole number in this case. Because this answer is very close to 65, it can be rounded up. Just wrote that out wrong, just realized. It's 64.948. Yeah, that's correct. And yeah, like I said, you can round this up because we're looking for a whole number, and it's very close to 65. The answer probably won't be an exact number, just like it wasn't here, but as long as you don't get something in the middle, like 64.56, then you will be okay rounding up. If you do get an answer which is kind of in the middle, then it could be a sign that something has gone wrong, and I would advise you to check your calculations. Anyway, that'll be all for this video and for the atomic structure section of topic 1. So I hope you enjoyed it, and I will see you in the next one.